So now we need to look at the concept of the pH scale. So the pH scale, we need to understand that water is a weak electrolyte and that the self-ionization of water can be represented by Kw equals H plus concentration times by OH minus concentration. So that being the constant for water is the hydrogen ion concentration times by the hydroxide ion concentration. And then we want to be able to know how Kw can be used to calculate the concentration of hydrogen ions from the concentration of hydroxide ions in a particular given solution. We also need to be able to understand that the pH scale is a logarithmic scale, and the pH of a solution can be calculated from the concentration of hydrogen ions using this relationship, which is pH equals negative log in base 10 of H plus. And then similarly to that, but not stated on this page, you need to be able to calculate that the concentration of the hydroxide ions can be calculated from the inverse of this. So that would be the concentration of hydroxide ions equals 10 to the power of minus pH. And then finally, we've got use appropriate mathematical representations to solve problems for hydrogen ion concentration, so that being H plus, pH, hydroxide ion concentrations, so OH minus, and POH. So here's just an example of the pH scale. So we can see that at 0, that's going to be things which are highly acidic. Coming up to pH 7 is going to be around neutral, and then pH 14 is going to be our maximum of alkali, so most basic. So we've got these two concepts and they're very closely linked. So we've got pH and POH. So the main difference between pH and POH is that pH is going to be known as a measure of hydrogen ions. So we sometimes call it the power of hydrogen. So that's what the small p stands for. And then the H is for the H plus. So it's the power of hydrogen. Whilst the POH is a measure of the hydroxide ions. So the power of the hydroxide. And so the pH and the POH of a neutral solution at 25 degrees Celsius is both going to be 7. However, it's important to note that these two are the inverse of each other. So a pH of 0 is going to be very acidic, whilst the pH of 14 will be very basic, compared with POH, where a POH of 0 is going to be very basic, whilst the POH of 14 is going to be very acidic. And so our formulas for these is we've got pH equals negative log of the concentration of hydrogen ions, whilst the POH is going to be negative log of the concentration of hydroxide ions.